And now for Chapter 9, we're going to set up our dependencies in Maven. In a Maven project, you don't need a lib directory, and you don't need to find and download any jar files. A big feature of Maven is that if you depend on a jar file that itself depends on jar files, you only have to list your dependency in the POM. Maven calls this transitive dependencies, and we're going to see what this means in action. Our project that we're working on needs almost 60 jar files, but we only directly depend on a small number of projects, and that's all we need to list in that POM. We'll also talk about scope and versions in a little detail, and we'll find out also where these jar files are being stored. It's not in a lib directory, but in an almost hidden location called the local repository. So we saw that one of the dependencies for this project is the Spring framework. Well, in fact, it's a bit more than that. We need the Spring MVC framework. As I mentioned, if you don't know what the Spring framework is, it really doesn't matter for this course, except that we need a jar file for that framework. So how do we tell Maven that we want to use the Spring MVC framework? Remember, there are a lot of jar files associated with the Spring MVC framework. We saw that a little earlier, and there's kind of like 30 or more jar files just for the Spring MVC framework. And it sounds at first like it might be a lot of work to get those jar files, but it's quite easy. All we need to do is to add an entry into the dependencies list. Inside our POM, I go back to my POM, I need to add in an entry in this dependencies list for the Spring MVC framework. Remember, we already have a dependency in there for JUnit, and in order to make JUnit become part of our project, we had to give the group ID, the artifact ID, and the version of JUnit that we want. And so we have to do the same for Spring MVC. Now, the only problem, of course, is how do we find out what those three strings are? How do we work out the group ID and the artifact ID? Well, the first way, and probably the most usual way, would be to look at the reference manual for the framework itself when we first start using that framework. So in this case, the Spring Framework Reference Manual will almost certainly tell us what the values we need for a Maven dependency are. And these days, any decent third-party open source framework in Java will publish its jar files to the central Maven repository, and they will tell us, probably on their download page, how to declare it as a Maven dependency. That would probably be the easiest way. Now, this is a little bit odd because we're kind of adding in the dependencies retrospectively after the project has been written, which is a bit unusual. And I think in that case, the easiest way is the second way. And that is, there is a website called mvnrepository.com. I'll pop up a caption there with the URL so you can see that more clearly. And this is effectively a searchable version of the central Maven repository. And using this website, it's really easy to find out the group and artifact IDs of really any open source project. Now, we want the Spring MVC framework, so all we have to do is go to the search box at the top, and I'll type Spring MVC and hit the search button. Now, it can be a little confusing because the search results will often list more than one project, but usually the one you're looking for is among the first few links. This is in fact the project we're looking for. And I can tell that because it's telling us that this is the org Spring Framework Spring Web MVC. That sounds like the right project that we want to depend upon. So I'm just going to follow the hyperlink there. And the next page is giving me a list of all of the available versions of this framework that really have ever existed, going all the way back to version 1.0. So there's a lot of different releases. Well, I can tell you that the project that we're working on was written against version 3.0.3. I'll talk a bit more about version numbers in a short while, but for now I'm just going to click the 3.0.3 version. Now make sure you have the Maven tab selected here. There are a few other tabs that we don't need right now. Inside this Maven box, wonderfully, is the exact XML that we need to add to our POM to make Spring MVC become a dependency of our project. And I can simply copy that to the clipboard, go across to my POM, and add it as a dependency. You want to be working inside the dependencies tag, that's an outer tag, and I'm going to paste inside there this dependency that I've copied in. Now usually the tags won't align properly, so I'll just do some indenting here just to make it look like better XML, and maybe a blank line at the end there. So let's have a look at what we've copied in here. We're telling our Maven project that we're depending on the Spring MVC framework. We've got the group ID correct. That's the group ID for all Spring Framework projects. And in particular, we want the artifact, which is the Web MVC framework. We're also being very specific about the version that we want, in this case version 3.0.3. Now notice that what we've copied in here does not have a scope tag. JUnit did have a scope tag, but this one doesn't. And that's because the default scope, if you don't specify a scope, and I'll type it in explicitly, is the compile scope. When we specify the compile scope, or if we leave out the scope entirely, then the jar files from, in this case, Spring MVC, will be available to our compiler, and it will appear on our runtime class path. And that's whether we're running our main application or if we're testing. Now I would say that probably most of the time compile is the scope that we want for our scope. We'll see some other options for scope in a short while. So you can either explicitly specify scope, or you can rely on the defaults by simply removing that line. Now you might think that this is just going to go and download a single jar file for the Spring MVC project, but actually Maven is a lot cleverer than that. Going back to the MVN repository page, and I'm still on the page for Spring MVC, if I just scroll down a little bit here to this item here, this artifact depends on, and it's giving me a long list, a really long list of group and artifact IDs. I guess there are 30, 40 different projects in that list. The Spring MVC project itself has dependencies on other open source projects. Let's find a quick example. I'll go for this one here, just at random. The Spring MVC project appears to use an open source project called Yoda Time. That's a kind of an improved date and time library, much better than the standard Java Development Kit's time library. And if I go a little further down, the Spring MVC project depends on a few other Spring Framework projects. For example, the Spring Beans part of Spring. Now the wonderful thing about this is that although we need all of these jar files as well, we're going to get most of these jar files downloaded for free, even though we've only added in one single dependency. And I'll explain why we won't get them all in a short while, but we're certainly going to get the bulk of them. So back to our POM. So remember that our original non-Maven project needed 56 jar files, but just by adding this single dependency, we're actually going to get the vast majority of those jar files downloaded for free. So I'm going to run this compile again, but before I run the compile, let me just remind you that previously, when we ran our build, we had a lot of errors. Now you have to hunt quite hard to find out how many errors. Well, it's saying 100 errors, and I think what happens is once it gets to 100 errors, it just gives up. But I want to see the difference now that we've added that single dependency, so let's rerun our Maven build. And notice that this time there are further downloads happening. It appears to be downloads for the Spring Framework, quite a lot of them. And this time around we still have errors, But if I find the count, this time we're down now to 40 errors, so a much improved build. So we still have 40 errors then, so we still must be missing some classes. And that's really just going to be because the project is using a few other open source projects that aren't part of the Spring dependencies. So we just have to identify the missing ones and add them to our POM. Let's go to the very first compiler error in the list. And it's saying that we're missing a package called javax.validation.constraints. Now, once again, you don't need to worry about exactly what this is. It's just a package that this particular project is using. But we do need to find out its Maven group and its artifact ID. This is a standard Java API. It's called the validation API. It's not part of the standard Java development kit, so you do have to download it, but it is a kind of a Java standard. But this is a little bit confusing. If you go across to the MVN repository page that we used before, now I'm still on the Spring Web MVC page here. And remember, we saw before that Spring MVC depends on a whole heap of other third-party projects. And I told you confidently that Maven will handle that for us, and it will download all of these other jar files without us having to declare everything inside our POM. But if you look carefully down this list, the Java validation library is appearing in the list of Spring MVC dependencies. Well, I told you a while ago about these transitive dependencies, and I said that all of these dependent projects would automatically become part of our project, and we would not have to list them in our POM. It does seem to have partially worked. We saw a lot of, for example, Spring Framework jars being loaded in our last build, but for some reason, the Java validation jar is not working for us. Well, for the answer, we can look at the POM for Spring MVC. Now, one of the great things about Maven is that as well as the POM that we're writing, all of the artifacts published in the Maven repository have their own POMs, and we are free to look at them. And you can learn a lot about Maven by doing just that. If you have a look at the link here, this will allow us to look at the POM file for Spring MVC, exactly as written by the creator of Spring MVC. So let's click on the view link. And I must say, it's really not a complex POM at all, even though Spring MVC is a really big project. So it's kind of good to see that real-world POMs don't need to be any more complex than the POM that we're building. They do have something called a profile listed here, which we haven't learnt about yet. But apart from that, really all there is in here is, as we did, they've declared a group ID, an artifact ID, a version, and then they're listing their dependencies. Feel free to have a good look at these dependencies if you have the time, but for us, the one that we're interested in is the validation dependency. So I just did a Control F there in my browser to find. I've typed in validation, and I've just found the first match, and that looks like the one we're looking for. The group ID is javax.validation, which sounds like the standard validation API, so this looks like the dependency that we're interested in. So it's certainly being declared as a dependency, but for some reason, in our project, we're not picking up the jar file for this validation API. Why not? Well, the answer is in the scope that the author of this POM has specified. Now, we've already seen the compile and test scopes, but this dependency has been declared as a third type of scope called provided. Now, what the author of this POM is saying is they're saying that Spring MVC needs the validation jar file in order to be able to compile, but the jar file is not needed at runtime in order to execute Spring MVC. Well, why would they do that? Well, in the case of the validation API, the jar file for validation is often provided by the web server when you deploy your application. For example, Tomcat has a validation jar file built into it. So, although Spring MVC needs this jar file in order to be compiled, it doesn't need it as part of the Spring MVC runtime, because it's expected that it will already be present. In other words, it will be provided by the runtime environment. So provided scope really means we need it to compile, but don't bother to package it in our WAR file. That also means any provided scope dependencies do not become part of transitive dependencies. So in other words, Spring is using the validation API to compile itself, but we won't get it as an inherited dependency. So I hope you've understood that okay. It's actually a really important point. I've worked with some people on projects who didn't understand this, and they thought that these transitive dependencies don't seem to work all of the time. So they would go and add every single jar file as a dependency in their POM, just in case, and they'd end up with really massive POMs. You really don't need to do that. So the upshot is, because our code is also using the validation API at compile time, we are going to have to add this dependency in manually into our POM. Well, it's easy to do. We could either go back to the MVN repository page and search for the validation artifact, or we could be cheeky, I guess, and simply copy this XML here, go back to our POM and add it to our dependency list, not forgetting, of course, to indent everything properly. So I'm going to add a comment to this one just for the purposes of the downloadable code, just to remind people, although Spring MVC declares validation as a dependency, it is set to provided scope, so it is not a transitive dependency. Now I'm going to talk about version numbers in a short while. We do need to think about the scope. It was provided for Spring MVC, but we might need a different scope. We certainly need it at compile time. I'm not sure if we need it at runtime, because I'm not sure which web container we're deploying this project to, so I think I'm going to be sort of conservative and remove the scope. And then this validation API will be part of our compile, but it will also be packaged up in our eventual WAR file. Okay, so that's an important point, and we can now rerun our Maven project. We had 40 errors before, and we're now down to 26 errors, so we're certainly getting there. Now, these remaining compile errors here are pretty much for the same reason. So for the next few minutes, work along with me and we'll pick out each of them in turn, and we'll eventually get down to a clean compile. I want to remind you here, this might seem really tedious, you know, this hunting through the list and trying to guess what the missing dependencies are. But that's only because this is a bit of a fake situation to take a project and to add in all of the dependencies at once at the end. Of course, in real life, as soon as we decided we wanted to use a particular library, we would have done a search, we would have got the Maven group and artifact ID and added each of them in as we go along. So in real life, this process is a bit more spread out. But anyway, let's go to the first of the compile errors. Now, you might think we've already added a validator package, but in fact, on this particular project, we use an extension to the validator package, which is provided as part of the Hibernate project. It's called the Hibernate validator. So we're going to need to add that to our POM. So back to the MVN repository, and I'll just search for Hibernate validation. The advertisement here can be a bit confusing because sometimes you look at this as being the first link. This is the first link, the Hibernator validator engine. Now we could go for any of these versions, but when we wrote the course, the current version was the 4.8 X series. So I think to go for 4.3.1.final. Again, I'm going to be talking a bit more about versions in a short while, but we can now just copy this dependency here and add to the POM. The next error here is that it's unable to find the javax servlet package, which you may know is another standard package in Java, but it doesn't come as part of the Java development kit. Just out of interest, returning back to the MVN repository, I've gone back here to the Spring MVC page. This is another one of those dependencies that has been declared by Spring MVC. There's javax.servlet, Servlet API, but once again, Spring have decided to give this provided scope. So they can compile against it, but it doesn't become one of the transitive dependencies. So it's this Servlet API that we need. And if I click through to that, I can pick my version. Version 2.5 is a perfectly good version to use. We didn't use any of the features that have appeared in version 3. So I'll click through to that and copy the dependency there. Now I just want to digress a little bit. You might know that the current version of the Servlet API is 3 point something. Now what appears to have happened is that they've gone as far as 3.0 alpha and then they've stopped. Now what's happened here is if you click on the JavaX Servlet link here, you'll see all of the projects associated with the JavaX Servlet. You'll see that they've done something quite odd. They've renamed their artifact. At version 3.1.0, the artifact is now called javax.servlet API. Now this is quite awkward, and I have no real way of making this any smoother. Sometimes projects do that. They rename their projects, they rename their artifacts, they change the way they work. And sometimes it's true, you do get very confused with that on a real life project. So what we can see from this though is it appears that if you want to use an old version of the Servlet API, you would use this artifact. If you wanted to use the very later versions, then you would have to use this artifact. Now because our project was written back in the version 2.5 days, we're safe to use the older one here. We happen to use version 2.5, so I'm going to copy this dependency. However, as I'm sure you're aware, projects in Java tend to maintain backward compatibility. So if you were to use the version 3.1 version of the dependency, then I'm sure everything would still work. Let's get that into our POM. I'm sure this isn't the most interesting thing you've ever done. If you're bored at this point, don't worry, we're very nearly there now. We go back to the compile errors. The next error here are 4 references to a package from a project called IText. Now this is a project that is capable of generating PDF documents, and that just happens to be one of the features of this website. So if we go to the MVN repository and type in IText, the first link is the one we need. And I know that purely because I know that the packages that we've been using on our project are called com. And this is just the name of the author of the library. If you look in the compile errors, you can see that we're using that same package name. Or you could look in this file here, the book report PDF. Now you have to be careful here. The version of the Spring framework that we're using will only work on version 2 of IText. And if you notice here, you'll see that they did a sudden jump from version 2 to version 4.2. The version you want is version 2.1.7. So again, we grab the dependency and drop that in, tidy that up a little bit, and then back to the compile errors. We've already handled the Servlet API, and it looks like we have just one more dependency. This is a package called org.apache.poi. That's a project that's capable of generating Excel spreadsheets, which is another feature of our website. You can see that we're referencing that from our file called book reports Excel. So we need the Apache POI project in our dependencies. Let's find that from the repository, Apache POI. And in this case, it looks like the second link's the correct one. Apache POI, a Java API to access Microsoft format files. Sounds good. And I'm happy to go with any version of this. I'd probably avoid the betas, so I'm going to specify version 3.9. So I know that wasn't the best fun you've ever had, but let's see if we get a clean compile. And we're expecting to see some downloads happening here. Let's bring in all these new jar file dependencies. Yep, there they are, POI and Hibernate validator. And wonderful, we're finally there. We have a build success here. And it's telling us here that it's compiling our 20 source files to, and now here's an important point, we have a new folder in our project called target. Here's my workspace, and if I go into the Maven project, you can see there that we have a brand new folder. There is our target folder. I think you can probably guess what's going to be in there. Inside there is a folder called classes. Notice it's not called bin. You might be more familiar with the binary directory being called bin. In Maven, they call it classes. And inside there is our compiled Java. So we're certainly not there yet. We need to be able to actually run this project and to deploy it to a web server. But at least we've finally reached our first successful compile. Before I move on, I just want to talk about good practice when using these transitive dependencies. And it's certainly a great feature that instead of having to find those 50 odd jar files that we needed in the Ant version of the project, we've just had to list just a handful of the projects that we're using directly in our code. Just looking back at the non-Maven version of this project, a quick example is that in the non-Maven version, we had to find this jar file called cglib.jar. Now, I don't know if you know what that is. It's a code generation library that the Spring framework depends upon. We need it, but we never referenced that in our code in our projects. So, as you know now, the transitive dependency meant that we got that for free. We didn't have to list it here in our POM. But let's imagine for a moment that the project has expanded and for some reason, I don't know what, but for some reason, you decide that you do want to use the cglib in your code. You might be writing a new class and you want to reference that cglib library. Well, in theory, you don't need to do anything here in your POM, because you've obtained the cglib as a transitive dependency and therefore you could start using it in your code. However, I recommend that if you do want to use a library from your code, then you should reference it in the POM, even if you've picked up that library as a result of a transitive dependency. That's because if the Spring MVC library changed its dependencies and maybe in the future they might decide not to use cglib anymore, then that would break our build because of course we would be depending on cglib and that would make our build a little bit brittle. Now, it is perhaps a nicety, but I think it is good practice that our POM should be declaring which are the important projects to our projects. So I can see at a glance, for example, that somewhere in the code, we are definitely using the validation API directly in our code. So of course, that was just an example. We're not using the cglib, but in the real world, if I did want to use the cg library directly from my code, then I would strongly consider adding it to the POM, even if I've acquired it as a transitive dependency. Now, there is a bit of an exception here. It's a debatable point, and we have, just off camera, had quite a bit of an argument about this. Notice in the code, I'm just going to go to this class here called Spring Client. And a good example is this class here, this class called Abstract application context. It turns out that this class isn't from the Spring MVC jar, it's from one of the transitive dependencies of Spring MVC. If you're interested, again, I've gone back to the non-Maven version of this project. It's one of the other Spring Framework jars. It is this one here, org Spring Framework context. Now, I've not had to declare that in my POM because, of course, I've acquired that as a transitive dependency. But it's a transitive dependency, and yet I'm referring to it directly in my code. So many people would argue that I should be listing the Spring context artifact in my POM. But for me, I like to think of Spring as one single big project. And I'm personally happy that by declaring Spring MVC, I get the other stuff for free. On some projects I've worked on, they prefer to list all of the components of Spring as separate artifacts in their POM. As I say, it's debatable, entirely up to you and your choice on your projects. It's your engineering judgment. And after all, as long as your code compiles and runs, then everything should be okay. I do like to balance things a bit. I don't like my POM to get too long here. And I think it's a bit strange that the Spring framework, it really is only just one framework, but they've split it into lots of different artifacts. I think they're trying to be as modular as possible, but it can be a bit of a pain to have to list all of those individual Spring artifacts. And one last thing that I want to say about transitive dependencies is that if you look on this list of transitive dependencies for Spring MVC, which you'll be quite familiar with by now, it looks like, for example, I'm going to pick a random artifact from this list. It looks like this one here, FreeMarker, is a transitive dependency of Spring MVC. But let's look at the POM for Spring MVC. And I'll jump down to the declaration of FreeMarker. Can you see here that there's another tag that we haven't seen so far on the course? It's called optional, and its value has been set by true. The optional flag means that Spring MVC needs FreeMarker in order to compile itself, and it might need that jar file in order to run. But as it's been declared as optional, then FreeMarker does not become a transitive dependency. So we'll find that FreeMarker isn't being downloaded as part of our project. It's as if whoever created Spring MVC and whoever wrote this POM has decided to switch off transitive dependency for FreeMarker. So if we wanted to use FreeMarker, then we would have to declare it in our POM. And you might think at first that's not very nice. Really though, it's probably a good thing, because many projects that use Spring MVC will never need to use FreeMarker. It is, quite literally, an optional thing that you can do with Spring MVC, but you can perfectly happily run Spring MVC without FreeMarker. So the architect of Spring has quite cleverly used the optional tag here to stop us having to download FreeMarker and wasting bandwidth and wasting time when we might never ever need to use it. You'll see indeed that many of these third-party dependencies as part of Spring MVC, there's another one here, Jasper Reports, that's true as well. Many of them in Spring MVC are set as optionals. We won't be using the optional tag in our POM, but I thought this would be a good opportunity to show you what it means. So now for a quick word on versions. So far we've been specifying exact version numbers in each of the dependencies that we've specified. For example, we've asked for version 3.0.3 of the Spring MVC framework. Now this version tag is a required field, so you can't just omit this tag and hope that you're going to get the latest version or whatever. But there are a few options available to us. So as an example, let's have a look at this Spring MVC dependency. So we're asking for version 3.0.3. Now that's actually really important because that was the most recent version of the Spring MVC framework at the time the project was written. And we are relying on a few bug fixes that were applied at version 3.0.3. So we definitely would not want to use any earlier version of Spring MVC. But it's possible, and I must stress here this depends entirely on your project. It depends on your project's configuration management policies, maybe your QA team or your testing policies. But it's possible that while we want at least version 3.0.3, we might also be happy to get a later version of Spring MVC if it exists. And as we go on building this project over time, if new versions of Spring MVC are released, we might want to pick up those later versions. Why would we do that? Well, perhaps we know that as the versions of Spring MVC increases, bugs are being fixed, and generally the quality of the framework is improving. And it's true that most Java frameworks work hard to maintain backward compatibility, and Spring in particular has a really good reputation for not breaking already working code. So maybe that's what we want, at least version 3.0.3, but a later one if it's available. And we can do that using the version syntax. Let's zoom in on this version number, and the way it works is like this. We can specify, I've just added a single square bracket there, the minimum version that we want to work with. Then I'm going to add a comma, and then I'm going to specify the maximum version that we want. So for example, we might know that the current version today is version 3.2.4, and I'm going to add a closing square bracket to say that that's the maximum version that we want. So here I'm saying I want any version from 3.0.3 up to and including 3.2.4. And Maven will simply find and download the latest possible version that matches that range. But we can be a bit more flexible than that. I could change this square bracket to a round bracket. And I'll just move the cursor away so I hope you can see that quite clearly. Now a round bracket means up to but excluding the specified version. So with the round bracket here I'm saying that I want any version from 3.0.3 up to, well, it's going to be 3.2.3. So I'm explicitly saying that I do not want version 3.2.4. Now the big use of that, and here is a kind of realistic real-world example, we know that Spring MVC is pretty stable. New features are added and bugs are fixed all the time, and we trust Spring not to break features. So perhaps on our project we would like to get the latest version where possible. We know that there's a big new version of Spring MVC coming up, and there is. It's version 4. I think it's around the end of 2013. But version 4 is going to be a big change. Now, it shouldn't be a breaking change, but it is going to be a big change. So maybe our QA department or our architect on the project or whoever, they might want to say, look, we want the latest possible version of Spring MVC 3, but we don't want to automatically upgrade to version 4 when it becomes available. So what we can do is we can modify this syntax to say, I'll leave the left-hand side as it is. We're happy for any version as long as it's at least 3.0.3, and we're happy to go up to version 4.0.0, but with the round bracket in place, that means excluding version 4. So that means any of the version 3 range will be acceptable as long as it's bigger than 3.0.3. And there is another option. Perhaps we've investigated Spring MVC 4 and it's not going to affect our project if we do get version 4. So what we can do is leave the version number blank on the right hand side. And sure, you can guess what that's saying. Any version number as long as it's bigger than 3.0.3. Another option, and it's not one that I would usually recommend, but you can just put in the string latest. Now this will pick up the latest version of this dependency even if it's just a development snapshot build. Now some projects, I don't think Spring MVC does this, but some projects will publish nightly builds to Maven with a tag on the end saying snapshots at the end of the version. Now this is a dangerous option, of course, but it's potentially useful for some projects who are maybe working on the cutting edge. But as a final option, you can also specify release, and that will pick up the latest version of this dependency that happens to be tagged with a release tag. And if we look back at the MVN repository, you can see that for quite a long time now, in fact all of the version 3 releases, they get a special tag on the end saying, hey, yeah, this is a production standard release. So by specifying release as the version, we're going to get whatever the latest production standard version of that dependency is. Now, in general, I don't recommend using that option because, of course, then we're opening up our project to problems if a faulty release for some reason of a dependency is uploaded to Maven. But at least the option is there. So I've just gone through a few options there, but for our project, I like the idea of going for any version 3 of the framework, as long as it's bigger than 3.0.3, all the way up to, but excluding version 4. So I'll use a round bracket right there. Now I'm going to run the Maven build again. So we're expecting to see new jar files downloaded here, and there you are. You can see now it's downloading lots of different versions of the Spring Framework dependencies. Notice it's downloading all of the matching sets of dependencies. It's currently downloading 3.0.7. Now it's doing 3.1.0. And you might find that a bit surprising. It's going to get all of the matching versions and it will keep them in our local cache. And then it will find the most appropriate version to build against, which will be the latest one. So that's going to take a while. It's now got what looks like the latest one, which is 3.2.4. And in fact, in this case, it hasn't needed to compile because we haven't changed any of our files since we last did a compile. I would like to force the compiler to run, so something we haven't done so far is run a Maven clean. I'll talk in more detail about this later, but if you right-click on your POM and select Run As, there is an option there for Maven clean. That will delete all of the compiled binary code from your target directory, and then we'll run Maven compile again. And of course, this time it won't need to do the downloading again because all of those downloads are now in our local cache, but it is still successfully compiling all of our source code. Something I haven't mentioned is when Maven is downloading all of these jar file dependencies, where is it putting them? In fact, what Maven does is it creates a hidden folder on your hard drive called M2. The M2 just stands for Maven 2. You'll find it inside your home directory. Now, if you're working on Windows, as I am here, you'll find that directory. Unless you've got a strange installation of Windows, you'll find that in your users folder on your C drive. You'll then have a folder for each of the users of this particular computer. My folder, by the way, is called Cybrandian, which is a bit strange. That's just because that's the name of this computer. We have strange names for computers at Virtual Pair Programmers. And inside there's the usual rubbish that you get in a home directory. But can you see there's a folder called .m2 that was created by Maven. And if you have a little drill around inside there, you'll find a repository. This is your so-called local repository, where your jar files are stored locally. If you have a look inside there, I certainly won't bore you with the details of what's in here, but you can probably guess. If we go into, for example, org and Spring Framework, there's a folder called web.mvc, and there are all of those versions that we requested in our POM, 3.0.3 onwards. And if we have a look inside 3.2.4, you can see inside there a jar file. You also get the POM, by the way, if you're interested, and these SHA1 files are just checksum files, so you can verify that you've got the right files, kind of for security reasons. But the jar file's the important one. So effectively, what Maven does when it builds is it first checks inside the .m2 folder to see if you have a local copy of your dependencies that you're asking for. And if it doesn't find it in there, it will consult the global central Maven repository. Sometimes, very, very rarely, you'll get some kind of corruption happening inside your M2 folder. One simple but possibly expensive way you can fix that is just by simply deleting the M2 folder. I'm going to do that right now. Looked like about 0.5 gigabyte of information in there. And now next time I run Maven, it will completely reconstruct that M2 folder by going to the internet and re-downloading everything. If you're on a Unix or Linux based operating system, including Mac OS, then you'll find the M2 folder inside your home directory. You'll need to pop up a terminal window, and if you just do a cd, that will put you into your home directory. Now, if I just do an ls, I'm not seeing anything because it is a hidden folder. The dot in front of it makes it a hidden folder. By the way, I am still on a PC because I've only got recording software for a PC. I'm using a program called Cygwin here to emulate a Linux or Unix based operating system. I'll need to do an ls option A, ls-a, to see all files in this folder. And if you have a look there, you can see your .m2 folder. So we've now ticked off one of the big hitting features of Maven, transitive dependencies. Our project needs almost 60 jar files, but we got most of those just by declaring that we are working with Spring MVC. Spring MVC itself needs lots of jar files in order to work, but we got those for free. The end result is that our POM will list only the libraries that we directly depend upon, usually the libraries we need to compile our code. I talked a bit about scope and versions. You now know about the test, compile, and provided scopes. And you can play around with version numbers depending on whether your QA people are happy for you to do that. Many projects use fixed versions. The jar files are hidden away. They aren't stored in your project, but rather in a local repository, a fancy name for a hidden folder in your home directory. If you delete that directory, your next build will re-download everything. And you might need to do that very occasionally if something goes wrong, if something gets corrupted. Well, that was a bit long, but we are now compiling. In the next chapter, we'll start to push Maven harder. We're going to look at how to work with Maven plugins.